I'm Talib Visram, and this is World Changing Ideas, where we investigate how leading innovators are solving our most challenging issues. On today's episode, fixing the housing crisis. Welcome to the show, Jason.
So happy to be here, and thanks for having me on.
So, 3D printing homes. I mean, this is mind-boggling. I don't even know where to start. Can you kind of take us step by step kind of through how you decided to even get into the business of 3D printing homes?
Yeah, I'll take you on like sort of a short journey, and if anything's interesting, we can double click and expand a little bit. But
Sure.
I actually studied conservation biology at university because I was very interested in humans learning to live in this world without undermining the things that make life possible. Fast forward, I maybe originally thought I might be a field biologist or something like that. But it turns out if you chase down the answer to the question, like, where are all these environmental problems coming from? At the time, at least, the surprising answer that came up over and over and over again was the built environment. And so I got involved in sustainable building, kind of at a grassroots level. I was building houses, swinging a hammer, helping out architects, helping out eco-handymen, doing anything I could to be a part of this, like, a better built world. Along the way, I got involved with starting a sustainable building supply and services company. And did that very happily for over half a decade. And I remember coming home from work one day and telling my wife, like, I love this work, but it's simply not making enough progress, right? Like making the thermostat 5% more efficient or the windows 3% cheaper to install. Like the problems are way bigger than that, right? And so kind of tinkering around on the margins of this current paradigm are not going to get us there. And so I set myself like a little research project of like, what are the things I care about for housing? What are the things that I think humans care about and value with regard to our shelter and our housing? And had a little spreadsheet, which is like cost, or speed of delivery, scalability, beauty, dignity, sustainability. And I researched everything. I looked at SIP panels and zip panels and shipping container houses and modular houses and prefab houses. Probably the weirdest thing I looked at was like architectural fungus. I don't recommend it. But only 3D printing, like even though it wasn't clear it was possible at the time, had potentially checked all the boxes. And so I did what all entrepreneurs do. I bought every book on 3D printing on Amazon. I went to 3D printing classes at the local tech shop, and with some friends started fabricating like a prototype construction scale 3D printer. And at each step, we didn't get all the way there, but it kind of built conviction that like this wasn't maybe as crazy. It was still crazy, but it wasn't impossibly crazy, that there was something worth chasing down. We eventually were able to partner up with my co-founder, Alex LaRue, who's our current CTO. But the sort of core conviction at the end of the day is that like it's time for the built environment to join the modern world. That like digitization and automation are going to do the things for this industry that they've done for other industries. And so another way to ask the question is like, why this automation? And the reason 3D printing is such a powerful automation, number one, is that it shapes the form and structure of the whole home, right? And it actually introduces new forms and new possibilities for architecture and residential vernacular. But then it does that with all, in a way that replaces like lots of trades all at once. When you 3D print a wall system, you get structure, you get insulation, you get the systems of the home embedded, you get internal and external finishing surface, you get all of these things. And so no other automation that we could discover was nearly so powerful as this automation. And so that's where we decided to start. And actually 3 years ago next week, we unveiled the first permitted 3D printed home in America, and it's been a wild rocket ride ever since.
Amazing. I'm just curious, did you initially, you really thought big. Did you think that big initially, when 3D printing was in its very kind of nascent stages, printing very kind of small things, was your mind already in, we could make a house like this?
Yeah, certainly. I actually pretty early. I remember the first time I actually sat down with like a desktop 3D printer. I have one here at the house. I still am fascinated by the technology, but I felt like it was a misapplication of the technology from the earliest days because people were using them to 3D print like plastic octopuses and spoons. And I don't know if you remember like the early days of 3D printing. It's like, that's completely wrong. Like those things are already very cheap. We make them very fast. And 3D printing so like 3D printing would be best on things that are big, slow, and bespoke, right? Like that would be right where 3D printing could be disruptive. So why are we using it on these things that are like small, fast, and cheap? Like that's the wrong application of the technology. So like I had a hunch that like this was a technology that like had an application to the benefit of the world, but that it was at a much larger scale.
Because you were thinking so big, there must have been some kind of challenges along the way. Can you talk about some of the kind of hurdles you may have come across early on?
Yeah, probably the hardest thing about working in this technology stack is that it's not just like a single problem. Like it's the sort of complex coordination of like multiple scientific, engineering, and I might even say like bureaucratic and sociological breakthroughs. And they all have to happen at the same time. In any one of them not happening could mean you're dead in the water. And by that, I mean, like, you've got to get a giant robot to move with like incredible precision, first of all, right? To even have a hope of depositing materials. You've got to invent sort of entirely new control systems and software to manage robots like this intuitively. And then the material that it extrudes or prints with has to behave that in ways that at the time there were no materials that behaved that way. Like extrudable concrete has to flow through the hose, because if it doesn't flow, you get a brick instead of a printer. But then it has to, as soon as you print, it has to set up and retain its shape in a load-bearing way very, very quickly. And there were no materials that behave that way. If you solved all those technical problems, then you had to convince sort of the bureaucratic, sociological powers that be to permit these structures. You had to get builders to adopt this method of building. Then you had to potentially get to a place where people would like bet their life on living in one of these things, right? And so if any of those things don't happen, this doesn't happen. And so that looked like a lot to bite off at the beginning. But like from the beginning, we've just sort of like broken down the problems to like in what order do we need to solve these problems and take them on one at a time. And like relentless and furious progress for the last 3 years is like, I think we are now ready to like open the gates and go. The joke at Icon is we've had a very sophisticated sales prevention program for the last 3 years. Like we've had tons of requests for homes and printers, but we knew that we had more problems that we wanted to solve, not all of which were technical, right? Some of them were architectural and other things, but we now feel we're ready to sort of say yes.
So the end product, the printer is the Vulcan, which is it's a great name, very vivid name. It's the Roman god of fire, isn't it?
Yeah, well said. Yeah. We have definitely a volcano thing going on because it was sort of like, what else spits out like liquid rock that gets hard and that shapes the world? And it's like, oh, volcanoes. And so like the printer's the Vulcan, the material delivery system is the magma. We call our concrete lavacrete. And then we have this like mantle system that we're developing for like improving supply chains and delivery of the concrete to the job site, et cetera. So it's like definitely a volcano thing going on.
Very cool. And how big? I mean, it's so hard to visualize. How big is the printer?
So the newest generation of the present generation of the printer, the outside dimensions of the printer is about 10 feet tall and a little over 30 feet wide, and then it can print about 30 feet wide and 8.5 feet tall. The new version of the printer that's actually about to be deployed to the field in the next 30 days, it's getting its final paces in the lab right now, can now print 12 feet tall and 40 feet wide. So we'll be able to print single-story structures easily, like up to 3,500, 4,000 square feet, which is sort of, at that point, you're at like 98% of single-story structures in the world. And we're also preparing, to be able to print multi-story as well.
Unbelievable. Like I said, it's really hard to visualize and even hard to visualize kind of the process for those of us who, printers to us mean, our inkjet printer. How can you kind of walk us through the actual printing process?
Yeah. So I'll start sort of like at the nozzle and then maybe like work backwards up the system. So like at the nozzle, what's going on is like our extrudable concrete is coming out on a tool path. And that tool path is determined by an architecture conversion software where we take architecture and we turn it into machine instructions. And then you build up the house layer by layer, right? So it's like layer 1, layer 2, layer 3. Our layers are about an inch thick, so we're sort of printing an inch at a time all the way up. One of the cool things about this technology is that like a slope or a curve or sort of these organic forms are just as easy and straightforward to print as a straight line. And no more expensive, right? So it really does open up these sort of radical and interesting, and I think, and many times like more human, not less human. What's inhuman is like squares, right? Like that's not our bodies, that's not the natural world. And so I feel like some of the architectural possibilities are actually more human. But that you print the wall all the way up at certain levels where the file specifies that like electrical or plumbing go in. The operator is inserting those things as we go up. So at the end, you have a complete wall system, including all the rough end for electrical and plumbing and that stuff. We then inject insulation around the whole top because it's open at the top. So you get sort of this like Yeti cooler of a house. I mean, it's an incredibly high performance, comfortable, energy efficient structure at the end. and then you cap it and anchor it to the foundation and then finish out as per usual. That's the present process. Upstream of that extrudable concrete is coming out of a system we call the magma. And what the magma is like a real-time, on-demand, extrudable concrete maker. To translate that, what that means out in the field is like the concrete we're printing with is different throughout the day because the temperature changes, the pressure changes. And so we have like a base mix, but then we have like a suite of admixtures that get added or not added in real time based on, hey, it was 45 degrees when we started printing this morning. That's today. And now it's 80 degrees in Texas. And so that's like a 40-degree temperature swing. And concrete behaves very different at all those temperature ranges. And the ability to precisely control the behavior of the material, even as the weather is quite dynamic, was like a huge breakthrough for us. So that's kind of how the system works.
Incredible. And what kind of materials do you use? Yeah, I think you mentioned lavacrete. Is that sturdy? I mean, is it hard to convince people that, you know, a home coming out of a machine is going to be sturdy?
Yeah, of course people have questions, and rightfully so. The good news, and we sort of did this on purpose, we explored like proprietary polymers and foams and some other materials. The great thing about concrete, there's a lot of great things about concrete actually, but one of them is like we've been using it for a few thousand years. And so we know what to expect out of the material. Most of the work we're doing on the material science changes what they call the fresh properties of the concrete, but once it's cured, it behaves like concrete. And so what you're getting is actually a more resilient, more strong structure than you would with conventional building and printing. In fact, I think one day the script is going to be flipped and people are going to go, how can we in good conscience keep building these stick frame houses when we know how inferior they are to concrete houses or whatever, right? Like, so there's like, we've just gotten used to wood, but wood is widely abundant in nature. But it's not, it has a lot of inherent properties that are working against it. Like wood wants to rot. It wants to be termite food. It wants to catch fire. It does not want to insulate. It has very little thermal mass. So it has all these things that you have to like work against. You have to do termite treatments and you have to insulate around it and you have to do fire retardants. And like, you almost have to get wood not to be wood so that it can be a building material. But with concrete, like you can let it be what it is. And it's already like a remarkably strong, remarkably resilient material. And pound for pound, it's the cheapest synthetic material we know how to make already. That's what before even Icon shows up.
Sure. So Jason, affordability, I think, is one of the issues that you set out to tackle when developing the technology. So how are you directly addressing driving down cost, especially for communities and individuals who can't afford to buy or build a new home? Yeah,
so the most direct thing we're doing, obviously, with an automation is we're replacing materials and labor. Once you've put forward the capital cost for the robot, the labor after that from the robot is free, right? And so that's true of all automations, and it's certainly true of ours. And we think sort of apples to apples today, depending on the architectural plan of the home, we are between 10 and 30% cheaper. Those are the direct ways. And that's just a one-to-one replacement of automated materials and labor with manual materials and labor. The other ways, however, we're addressing costs that are more indirect, but I would say equally important. The first indirect one is speed. We are a lot faster than conventional construction, if nothing else, because we like specifically designed the robot to like just print. It doesn't take a smoke break. It doesn't drink a beer. It doesn't sleep late. It just runs the file. It doesn't call it significant other. It just prints houses. And there's actually no reason that these robots couldn't be running 24 hours a day, which is 300% longer than a typical workday. And so that speed indirectly has an impact on cost as well. If a developer is building 100 or 1,000 houses and they can get those houses finished 6 months, a year faster, and they're not having to pay interest on whatever loan they pulled down from a bank, those costs don't get passed on to home. So it's a little bit indirect, but profoundly powerful in reducing yet another chunk of the cost of the home. And then the third big area for reducing cost is architecture in two ways. Number one, we're able to optimize architecture for 3D printing that makes it even faster and cheaper rather than just like one-to-one printing the house the way it is that's sort of developed for stick framing. And the other is like once we create an architectural file, it's software, and that architecture from then on is free. In an average sort of custom home, like architecture is 10 to 15% of the cost. Mm-hmm. With Icon, architecture is free once we've created it. And so over time, building this like catalog of homes that are designed in accordance with like our very highest values and principles. You get free architecture, you get automated materials and supply, you're going a lot faster, reducing carrying costs of construction projects. All this adds up to like a very unfair advantage at the end of the day. So that's a bit long-winded, but I hope it's a helpful framing.
Yeah, no, totally. And can you talk a little bit about your very first kind of, I believe it was your first partnership with News Story?
Yes. Yeah. So it was, this icon was born out of a frustration with the housing situation, especially on behalf of those who have the hardest time getting into good housing, right? Like, that's sort of like really like, oh, it's 2018 at the time. Like, we got to be doing better than this. Yeah. And so it was really wonderful that our very first paying customer, our very first partner, was somebody who wanted to point the technology at the needs of the very poor. And the very poor are often the very last people to get access to breakthroughs in technology and material science. And so it was lovely in that sort of romantic human way, but it was also like learning to build houses that cheap in remote areas like Mexico was like the deep end of the pool. And so it forced the technology to grow up a lot faster and with a lot tighter restrictions than we would have, say, if we had started out in middle market housing. And so it like forced us to grow up and innovate very, very rapidly. And so it ended up being sort of like a forcing function for innovation as well. And they have just been like delightful partners. And I can't commend them enough for their bravery on taking a bet. Because it can't be that we only innovate for people who can pay for it, right? Like it's a brave thing to try to innovate. And innovation is synonymous with risk. Like somebody had to take a risk and not be sure if they're going to get their money back. But those risks need to be made for the very poor, or who, because they can't take those risks on their own behalf. And so I'm proud of News Story and the work that we've been able to do together.
Are there any more of those sorts of projects, collaborations on the horizon?
Yes, absolutely. We hope to have a very, very, very long-term partnership with News Story. We just wrapped up our first kind of pilot project of 10 homes down in Mexico, and we're in the midst of like planning right now what's next for our organizations. In addition to our work with News Story, that opened the door for us to do additional kinds of collaborations here stateside. Like News Story has a very solid international focus. But we've been able to partner with a local organization here in Texas called Community First Village. The parent nonprofit's called Mobile Loaves and Fishes. And we delivered a series of 7 homes for that organization that are in for people experiencing chronic homelessness in Central Texas. And the first residents have moved into those homes. They just went through, sort of snowpocalypse or snowvid, whatever you want to call it, here in Texas recently. And the reviews were glowing. These are people that in the not too distant past would have been sleeping under bridges in tents during this. And I think Tim, one of the gentlemen who moved into the houses, Tim, was doing an interview or something about it the other day. And they asked it, so Tim, how'd the 3D printed house do during the blizzard? And he said, what blizzard? And for a man who formerly lived on the street and probably shivered his way through even mild winter nights, to be able to say that, I mean, it's like, this is the way. This is the kind of innovation we need and what we need to be doing with it. So,
yeah, no, absolutely. So here's the, I think, most exciting part now. As if it wasn't exciting and big thinking enough, you're looking into off-world construction systems, which is essentially printing in space, right, on other planets. So how did the partnership with NASA come about?
Yeah, so my graduate studies are in space resources. So this is sort of something like in my weird, eccentric person that I am, that this is sort of like part of who I am sort of from the way back. And we began talking with NASA literally the very same month that we unveiled the 3D printed home 3 years ago, because they had what they call a Centennial Challenge open at the time for 3D printing habitats on Mars. And Centennial Challenges are the way that NASA explores public-private partnerships to advance and develop technologies that they're interested in. So we were an award winner and a finalist in that contest, and that opened the door for continued negotiations afterward. And it has just been an incredible. We are going back to the moon to stay. That's the word from NASA, and we're doing it this decade. The first woman is going to put boot prints on the moon, but we're not just planting flags. Like we are actually going to begin establishing a permanent presence on other planetary bodies like the moon and ultimately Mars. If we want to do that, we can't carry everything with us anymore. Like that works if you're just going to go plant a flag and come home. You just it's like a camping trip. But going to move somewhere is different than going camping somewhere. And we ran the sort of numbers on just bringing up the concrete that we used to print our first habitat that was only 350 square feet would be like close to $1.5 billion just for a small little tiny structure. We're never going to have a moon base that way. What we're going to have to do is go up with a single system that can use the local resources, what NASA calls in situ resource utilization, ISRU. We're going to learn to live off the land and build with what we find on the moon and Mars. And that way you have a single system you transport one time. And then that single system can build launch and landing pads, roads, unpressurized structures, pressurized habitats without the reoccurring cost of like, I think it's like $15,000 per pound or kilogram to get something to the surface of the moon. Like this is, we can't do that. We're going to learn to live off the land, like humans always have had to do when they explored and expanded to new places.
So once again, how is the question? How do you print on other planets? How, and how far into the horizon, into outer space is this goal? Yeah.
So the two sort of, regardless of whether you're going to Mars or to the moon, the two sort of really common elements are ISRU, the principle of living off the land. So you're not spending billions and billions and billions of dollars every time you want to build anything. And the second one is autonomy, right? We're going to really turn autonomy up to 11. We have to be able to control and operate these things without any humans necessarily on site and present. After that, it gets very different. The moon is a very different place from Mars. Mars has an atmosphere. Mars has water. In some ways, Mars has more gravity. In some ways, Mars will be like much easier to build on than the moon. But we're going to the moon first. And so we get to jump in the deep end of the pool. With the moon, the biggest difference for us is like we can't use water-based concrete anymore. Number one, because if you had water on the moon, you would use it for life support or maybe rocket fuel, but you would not build out of it. It would be like building out of like platinum on Earth. It was too expensive, too valuable. And so, and then even if you wanted to build out of water, it sublimates on the moon. It goes straight from an ice to a gas. And so there's no liquid water. And so we're going to have to take the local geology of the moon and mostly like straight up melt it. Almost actually a lot more like a desktop printer where you're like melting the plastic. What are we going to use to melt the plastic? Our best thought so far is some version of the electromagnetic spectrum, probably lasers, i.e. visible light, but we're also experimenting with microwaves and infrared. And if all that fails, we'll straight up put it into a furnace and extrude it out of an extrudable furnace. We're exploring all those possibilities right now. We have some early winners. I don't want to say too much because like things could change. We're still early in the research phase, but we have been able to produce objects using lunar dust, simulated moon dust with all the methods I've just described. Like we have done it. We have printed things out of moon dust in the lab with infrared, with lasers, with microwaves, and just straight up melting it. So this does not defy the laws of physics, and the materials is like quite strong. So we're really excited about this being a viable path forward.
Incredible. And how might that building help address housing issues back here on Earth?
I'm so happy you asked this question because I often get asked it sort of assumes the best in the way you phrase the question. I often get asked the question like, are you guys confused or distracted? Like, what's going on here? Here's the best way I can answer that question. It's almost like as a civilization, we need to level up to solve a lot of the problems that we have right now. I don't know what level we're at. Like maybe we're level 7 like that. But the idea is like, we need to become a level 8 civilization. And a level 8 civilization, I just made that number up, is both spacefaring and able to solve homelessness, for instance. And I think the kind of civilization that learns to explore outer space and to live in outer space will be the kind of civilization that is able to solve homelessness. And conversely, learning to build in space, all of those insights are already cross-pollinating back into our terrestrial technology, making it faster, making it more autonomous, making the material science better. And so it really is one of these pictures of like, often you have to sort of advance in big paradigm shifting ways. You can't just sort of say like, oh, we're going to focus on homelessness. Oh, we're going to focus on a moon base. It's like, it's by expanding the aperture as wide as possible that you let in the maximum amount of innovation, the maximum amount of funding, and then you do all of that on behalf of humanity. And that's sort of what's going on. That I think these things go together, and that if we, it just may turn out that like the solution to some of our problems on Earth are going to be found on the moon. Now, like that's the bet. I may be wrong, but that's the bet we're placing.
So back here on Earth, Jason, using robots to build houses, is this kind of the mark of a new industrial revolution?
Yeah, I certainly hope so, right? We don't believe that we are just sort of a niche kind of, this is a neat little thing to do sometimes for housing. We think this is a profoundly better way to do housing. It is faster. It is cheaper. It does offer more design freedom. It offers higher speed. It offers scalability. It offers sustainability, not just in the building performance, but when you 3D print, you print what you need to the drop and then you stop. And that's cool, not just because it rhymes, but because if you've ever been to a job site, there's often more waste than house, or at least that's what it feels like. And so I think this is the toolkit of the builder of the future. And buildings are among like our most foundational human needs, right? Like food, water, shelter. And anytime you actually change a paradigm on one of those fundamental human needs, this doesn't happen very often, like on the order of millennia. It has an impact. That I think revolution is the right word.
And do you think companies will start catching on in the future? And could this kind of be a way to start addressing the housing crisis?
That's the bet, right? Is that like we need to bring the very best of our innovation, our creativity, and our energies to bear on some of humanity's most pressing problems. Like Icon is a company in service to humanity. That's a thing we say a lot internally. And that's exactly what we're after. Is like, this isn't just for like the wealthy. It isn't just like to add a neat little frill facade to your house. This is about fundamentally solving human problems. And I think I won't say that there's no risk left. I won't say that we don't have things left to do. But I think a lot of the risk has gone out of the balloon. Like all the major, like, can a robot behave this way? Can materials behave this way? Can you get it permitted? Do humans want it? Is it nice to live in? The answer to all those questions is yes. And part of the way that we'll know that this revolution has caught on is, in fact, exactly what you referenced there will happen. Other companies will begin doing this. Other companies will begin supporting this. I think in the future, there will be college classes in the School of Architecture on design for 3D printing. I think architects will start designing for this. I think window companies will start making special windows that fit into 3D printed houses. I think paint companies will develop special paints that are even better on 3D printed surfaces and things like this. And that's what a paradigm shift means, right? Right now, the whole industry, the whole construction industry is organized around old ways of construction. And I think if this works, we're going to have to completely reorganize the way that we do architecture, the way that we do construction, and the way that we live and shelter ourselves. It will change the way the surface of the earth looks, and maybe even the surface of the moon and Mars.
Yeah, truly amazing stuff, Jason. Really mind-boggling, and I can't wait to move into my mansion on the moon.
We'll put you on the list. I know a few people. We'll make sure you're on the short list.
Right. Can I get a pool? Can you print a pool?
Yeah, we could probably just like print a dome and turn it upside down and fill it with water, and there you go.
Awesome. Well, Jason, thanks so much for coming on the show. Really appreciate it.
Of course. Happy to have been here. Thanks for helping me tell this story.